In this video, I want to show you the essential configurations needed to use this build, along with a Python script that simplifies starting Kismet to log Wi-Fi access points. Always connect the Raspberry Pi's power supply first, and then the USB hub's power supply, otherwise, the Raspberry Pi often fails to boot. I activate the access point configured on the Raspberry Pi using this switch. For remote desktop access, I chose Na Machine. I'm using the computer for convenience, but this software is available for both Android and iPhone. The first thing to adjust is the display resolution because, with the Raspberry Pi 4, I can't change it dynamically during a Na Machine session, whereas this is possible with the Raspberry Pi 5. I chose a resolution of 800 by 800, which suits the screen size of my smartphone well. The next step is to configure the access point using the Raspberry's built-in Wi-Fi module. I configured the Wi-Fi adapters as unmanaged because Network Manager, even when an adapter is configured as an access point, still scans for nearby Wi-Fi networks, which can cause lag during remote connections. I didn't completely disable Network Manager because I still use it to connect to my Wi-Fi network for internet access via an additional USB Wi-Fi adapter. I plugged this Wi-Fi adapter into the USB hub, and Network Manager exclusively uses it to connect to my Wi-Fi network. It automatically connects as soon as I insert the adapter. I configured the access point using hostapd. Here's the configuration file, which I'll share on my website in the page dedicated to this build. This is the script that manages the activation and deactivation of host app using the switch I showed earlier. This will also be available on my website. Now let's move on to Kismet, which I use to log Wi-Fi access points along with their location information. Kismet generates files in Weigel CSV format, and this is a Python script that makes using Kismet more convenient. At the beginning of the script, there are a few variables to configure, such as the folder where Kismet should save data during operation and the folder where files will be archived later. I'll explain this in more detail shortly. To start Kismet from the script, select option 1 and press enter. To end the session, choose option 2. This is how the Kismet web interface appears on the smartphone. At the moment, it only shows my Wi-Fi access points and no GPS signals because I'm in a shielded environment. Option 4 shows the recorded SSID after cleaning up duplicates, keeping only the ones with the strongest signal. You'll need to decide whether to exclude specific SSID or MAC addresses by entering them manually during execution or in the script itself. For example, I've listed the MAC addresses of my devices. This script never modifies the original Weigel CSV files. Instead, it creates a cleaned-up CSV file that automatically opens with system's default software, in my case, LibreOffice Calc. This is a sample placeholder file. Option 5 generates a map with red dots for each SSID. The same cleaning options from option 4 apply here. Again, it doesn't alter the original WigLex files, but creates a temporary dataset. Maps can be generated either online or offline using tools like TileServer GL. The script allows you to configure whether to fetch maps from the internet or use offline maps. Option 3 lets you archive Weigel CSV files by creating a folder structure based on their creation date or the date you run this command. You can configure this behavior through a variable. Now, I'll archive the files to my Backpack Samba server, but they can also be stored in local folders on the Raspberry Pi. The script will be available on GitHub, and the link is provided on my website, bagbuilds.com. That's all for today. If you have any questions or suggestions, feel free to leave a comment.